Hi everyone, so welcome to my channel. Myself Raza, and in this video I am going to discuss some more important multiple choice questions related to the chapter mensuration. Right? So please try to watch the video till the end. So don't skip the video. If you like the video, please share with your friends. Right? Now let us see question number 1. The total surface area of solid hemisphere of radius 7 centimeters is. So here the radius is given as 7 centimeters and is asking you to find out the total surface area of solid hemisphere. So total surface area of solid hemisphere is given by 3 times of pi r square. Now if you observe this carefully, in the options we are having pi, so no need of changing pi as 22 by 7. So we can write as 3 pi into 7 square. So which is nothing but given by, so 3 pi into 49. So when you multiply, so 9 3s are 27. So 2 is carried, 4 3s are 12. 12 plus 2 is 14. So this is nothing but 147 pi centimeter square. Right? So in the options, if you observe, you don't have that option. Hence the answer is 147 pi centimeter square is my answer for this question. Next, coming to question number 2, the curved surface area of right circular cone of height 15 centimeters. So height of this particular thing is given as 15 centimeters and base diameter. So here you need to observe carefully. So diameter is nothing but 2 times of radius, which is given as 16 centimeters. So from this radius is equal to 8 centimeters. Now what did he ask? Curved surface area of right circular cone. So curved surface area of right circular cone is nothing but given by CSA is equal to pi r L. Pi r L. Since we don't know the slant height directly, I can write it as pi r into square root of h square plus r square. Right? So instead of L, I can write directly h square plus r square. Now substituting the values, since all the options contains pi, so pi into r is 8 into square root of 8 square plus 15 square. So since it is a Pythagorean triplet, 8 square plus 15 square is nothing but 17 square. So this gives me 70. Now when I multiply 7 8s are 56, 8 ones are 8 plus 5, 13. So 136 pi centimeter square will be my answer here. Hence option B is my answer. Next, a conical flask is full of water. So a conical flask is full of water, so which is having height h centimeters and radius is r. Now this particular thing is filled in a cylindrical beaker or cylindrical flask, so which is having radius mr, and he is asking you to find out the height of the cylinder. Now so when this particular quantity is transferred into this, then volumes will not change. So from this what I can say, so volume of cone is equal to volume of cylinder for the given measurements. Now volume of cone is nothing but given by 1/3 pi, so r square h is equal to volume of cylinder is nothing but pi into what is the radius of this, so radius is m into r, so m into r whole square into height of the cylinder. I need to find it out, right? So height of cylinder I need to find, so on both sides I can cancel out pi and pi. So from this, height of the cylinder h suffix cy is equal to, I can write it as, so this is r square into h by 3 into this mr whole square can be brought to the left hand side as 1 by m square into r square. Now clearly here r square gets cancelled. Now this I can write as h by 3m square. H by 3m square. Hence the answer is option A. H by 3m square. So height of the cylinder is height of the cone by 3m square, right? Next, moving on to question number 4. The surface area of two spheres are in the ratio 1:4. Then the ratio of their volumes. So already, so we know CSA 1 by CSA 2. So CSA 1 by CSA 2 is nothing but given by R1 square by R2 square. So when we talk about spheres, so curved surface areas of those two spheres are in the ratio r1 square by r2 square. Now based on this, so 1 by 4 is equal to R1 by R2 whole square. So from this I can say R1 by R2 is equal to 1 by 2. So when square is transposed, it becomes square root. Square root of 1 by 4 is 1 by 2. Now what is he asking? Volume. So V1 by V2 can be written as R1 by R2 whole cube. So which is nothing but 1 by 2 whole cube. So which gives me 1 by 8. Hence the answer is 1 by 8. So surface areas of the two spheres are given in the ratio 1 is to 4. Then the ratio of their volumes is asking. So 1 is to 8 is my answer. Right? But there is no option 1 is to 8. Okay. The answer here is 1 is to 8, or you can change it as 1 is to 8. So from this, option B is my answer. Next, the volume of the largest circular cone that can be cut out of a cube of edge 4.2 centimeters. Now there is a cube. So from this cube I need to cut out a cone. So what is the largest cone that we can cut it out? So from this what I can say? So height of cone is equal to side of cube and the radius of cone. So the radius of base of cone is equal to side by 2. So let the side be A, then the radius will be A by 2. Right? So here the side length is given as 4.2 centimeters. So this I can write as 42 by 10. Next radius can be written as 42 by 10 divided by 2, which is nothing but 21 by 10. So height is 42 by 10 and radius is 21 by 10. Now what I need to find? Volume of the circular cylinder. So circular cone. So volume of cone is given by, so 1/3 pi r square h. Now substituting the value, since we don't have pi, so we need to write it as 22 by 7 into radius square. So radius square is nothing but 21 by 10 into 21 by 10 into height is 42 by 10. So from this clearly 7 3s are 21. So we can cancel it out. Now directly multiplying the values, so which are present in the numerator. So 22 into 21. So 2 ones are 2. So 2 ones are 2. 2 twos are 4. 2 twos are 4. So it is 462. So multiplied with 42 again. So 2 twos are 4. Right? So 2 6 are 12. 4 twos are 8 plus 1 9. Next 4 twos are 8. 4 6 are 24. 2 is carried. So 4 4 16 18. So from this 4, this is 0. 9 plus 1 10. 10 plus 4 14. Next 8 plus 1 9. So 19404. Hence the value is 19404 divided by 10 cube. So since we are having 10 cube in the denominator, this can be written as 19.404. So from this, option A will be my answer. Right? Next, the diameter of a metallic sphere is 6 centimeters and melted to draw a wire of diameter 2 centimeters. Then the length of the wire is. Now what is he asking? So a sphere is melted and converted into a wire. So wire is nothing but in the shape of a cylinder. Here the metallic sphere diameter is 6 centimeters. So diameter of this particular sphere is 6 centimeters. So from this R is equal to 3 centimeters. Now talking about the cylinder. So cylinder also the radius, the diameter is given as 2 centimeters. That means 2R is equal to 2 centimeters. So from this R is equal to 1 centimeter. So these particulars are related to sphere and these particulars are related to cylinder. Right? So this R is related to sphere and this R is related to cylinder. Now based on this, so when one thing is converted into, so one shape is converted into the other, volumes will not change. So volumes will not change. So from that what we can say, volume of sphere, so 4/3 pi r cube will be equal to the volume of cylinder. So volume of cylinder is nothing but pi r square h. Now here, since this is related to sphere and this is related to the cylinder, hence I am writing the suffixes. So on both sides I can cancel out the pi's. Now substituting the values 4 by 3 into radius of sphere is nothing but 3 into 3 into 3, which is equal to radius of cone is 1 square into h. So here 1 3 will get cancelled with 3. So 3 3s are 9, 9 4s are 36. Hence height is nothing but, that is nothing but length of the cylinder is nothing but, so 9 4s are 36 centimeters. Hence the answer is 36 centimeters. Next, a solid sphere of radius r melted and recast into the shape of a solid cone of height r. Then the radius of the base of the cone is. Now here you can see that sphere is converted into a cone. Sphere is converted into a cone. So from this what we can say? The volume of sphere. So 4/3 pi r cube is equal to volume of cone. So volume of sphere is equal to volume of cone 1/3 pi r square h. Now if you observe the things carefully, here the radius of the cone, that is nothing but r, is equal to the height of the, so height of the cone. The radius of the sphere is equal to height of the cone. Now replacing the values, so instead of h I can write r, and instead of r I can take it as r suffix c. Now simplification, so by 3 will get cancelled, pi will get cancelled, and now what I am left over with, so I am having 4r cube on left hand side, and on the right hand side I am having rc square into r. So here in r cube this r cancels r square times. Now here this rc square I can write it as 2r whole square. On comparison, so the radius of cone can be written as 2 times of r. So radius of cone is 2 times of r. Right. Next, moving on to question number 8. The ratio of volume of cone and cylinder of equal diameter and equal height is. So already we have discussed. So volume of cone divided by volume of cylinder is nothing but given by, always cylinder will have more volume. So it is 3 and volume of cone is 1. So hence the answer is 1:3. So cone always will have lesser volume when compared to cylinder. So cylinder will have 3 times the volume of a cone. Right. Next, the solid iron cuboid of dimensions is melted to form a solid sphere. Then its radius is. So clearly, so what he has done? So he has converted cuboid into a sphere. So cuboid into sphere means we can simply say volume of cuboid is equal to volume of sphere. So 4/3 pi r cube. Now substituting the values. So length is 49 into breadth is 33 into height is 24 is equal to 4 by 3 into 22 by 7 into, so r cube. So I need the radius, right? So for this, so what I can do simply is convert these into prime factors. So 49 I can write it as 7 into 7, 33 I can write as 3 into 11, and 24 I can write it as 2 cube into 3. Right, so 8 3 is a 24. Now these things when I transpose to left hand side, so this I can write as 4 by 3 can be written as 3 by 4 into 22 by 7 can be written as 7 by 22, which is equal to r cube. Now what are the possible cancellations we have? Now this 4 into cube it cancels 2 times. Next 2 11s are 22. So what are the cancellations we have? So we have cancelled them. Now what I am left over with? So here we have two sevens and there is one more 7. So this gives me 7 cube, and here I am left over with the 3 threes. So 3 cube, which is equal to r cube. So from this r can be written as 7 into 3, which is equal to 21 centimeters. So if you multiply, so then it becomes somewhat difficult to do. So that's why, so you need to make use of prime factorization, right? Next, if the radii of circular ends of a frustum of cone are 20 centimeters and 12 centimeters and its height is 6 centimeters, then the slant height of the frustum is. So is asking you to find out the slant height. Now for suppose, so what he has given, so the top part is 12 centimeters and the bottom radius is 20 centimeters, right? So the radii of circular ends of these two parts. So this is 12 centimeters and this is 20 centimeters. Now, since from vertex to, so from center to center, that is nothing but the axis. So when you join, so it will be perpendicular, right? Now when you join the ends, so this is nothing but we call it as slant height. Now I need to find out the slant height, right? And he has given that this height is equal to 6 centimeters. Now by looking at the figure itself, you can directly find out the value. If this is 6 centimeters, so from here if I drop a perpendicular, then this will also be 6 centimeters. Since this length is 12, then this particular length is also 12, right? So if this is 12, then what is this remaining length? So it will be 8 centimeters. So 6 square plus 8 square will be equal to 10 square. So by using Pythagoras theorem, so we can say slant height is equal to 10 centimeters. Here no need of knowing about any formula, right? So no need to remember any formula. So simply you can go like this, right? So for suppose if you want to go with the formula, so what will you do? So if you want to find out the slant height, so slant height is equal to square root of h square, right? So clearly this is h square plus this particular part is nothing but this capital R square minus small r square. So we can say that, sorry, not capital R square minus small r square, it is capital R minus small r whole square, right? So using this formula also you can do it, right? So this is the formula you can make use when slant height of a frustum of cone is asked. Next, the number of balls each of radius 1 centimeters that can be made from a solid sphere of radius 8 centimeters is. So here volume to volume, so here shape is being changed, that means volumes will not change. So here I am having a sphere of radius 8 centimeters and this particular 8 centimeters sphere is converted into n times of sub small spheres. Okay, so from this what I can say, so volume of this big sphere will be equal to n times of volume of each small sphere. Okay, so from this what I can say, 4/3 pi into capital R cube, which is equal to 4/3 pi into 8 cube is equal to n into 4/3 pi small r cube. So small r cube means, so here r is nothing but 1. So 1 cube. So 4/3 pi, 4/3 pi, I can cancel it out on both sides. So 8 cube is 512, which is equal to n into 1 cube is 1. So here the value of n is 512, right? Next, moving on to question number 12. An iron cylindrical rod has height 4 times its radius. So here what he has given, so height is equal to 4 times the radius. So this is regarding cylinder, right? So if radius is r, then height is 4 times of r. Now this particular cylinder is melted and cast into spherical balls of same radius. So for sphere also the radius is same as cylinder. Then the number of balls that it can cast. That means, so volume of cylinder is equal to volume of sphere. So what is volume of cylinder? So pi r square h is equal to, so what about sphere? So sphere is nothing but 4/3 pi r cube. So here height can be replaced with 4r. Now instead of h I can write 4 times of r. Now simplification. So pi gets cancelled. Now since what did he ask? So he is asking number of spherical balls that he can form. So number of spherical balls means, so this particular volume will be is equal to n times of volume of sphere. So I need to find out the value of n. So based on this, so pi gets cancelled. Next 4r into r square means 4r cube. So this 4r cube and this 4r cube I can cancel it out. So on doing cross multiplication I am getting the value of n as 3. Hence the number of balls I can form is 3. Right, next the ratio of volume of two cones is 4:5. So V1 by V2 is equal to 4 by 5. Next what he has given, the ratio of the radius of the base is 2:3. So R1 by R2 is equal to 2 by 3. Now then the ratio of the vertical heights is, so the ratio of vertical heights. Now based on this already I know volume 1 by volume 2 is given by, so already volume of cone is 1/3 pi r square h, right? When you take V1 by V2, so 1/3 pi R1 square H1 divided by 1/3 by R2 square H2. Here since 1/3 by 1/3 pi is constant, so no need of writing 1/3 pi. Only the things so which vary are R1 square H1 by R2 square H2. Now substituting the values, whatever the values we know, so this one is 4 by 5 is equal to R1 by R2 whole square, which is nothing but 2 by 3 whole square into H1 by H2. Now based on this, so what is the value of H1 by H2 then? So H1 by H2 is equal to already 4 by 5 is there on the left hand side. This 2 by 3 whole square means 4 by 9. When I transpose, this becomes 9 by 4. So 4 gets cancelled. Hence the answer is 9 is to 5. Hence the answer is 9 is to 5. Next, a cone and a hemisphere of equal bases and equal volumes. Then the ratio of their heights is. So since they have equal bases. So equal bases in the sense they are having equal radius. Right. Next he has given equal volume. So equal volume means, so we can say 1/3 pi r square h is equal to, what is the volume of hemisphere? So volume of hemisphere is nothing but 2/3 pi r cube. Right. Now since both the radius are equal, I can cancel this 3 and 3, pi and pi. Next in r square 1r and this. So r square in r cube it cancels r times. Now from this h is equal to 2 times of r. Now what do I need? I need to find out the ratio of their heights. If you observe the height of the height of hemisphere is nothing but the radius. Right? So by taking them in order, h by r can be written as 2 by 1. Hence the answer is 2 is to 1. Next, the volume of a vessel in the form of a right circular cylinder is 448 pi centimeter cube and its height is 7 centimeters. Then the radius of the base. So already volume of right circular cylinder is given. That means pi r square h is given as 448 pi. Now on both sides I can cancel out pi and pi. Next, height is given as 7 centimeters, so I need to find out radius. So r square into 7 is equal to 448. Now in 7 table, 7 6 are 42, 7 4s are 28. Now from this r is equal to 8 centimeters. Hence the answer is 8 centimeters. Next, moving on to question number 16. The volume of the greatest cylinder that can be cut out from a solid wooden cube of length of edge 14 centimeters is. Now, so what is the largest cylinder? So largest cylinder is nothing but, so you are having a cube, right? So from this cube, I need to remove a cylinder, so which is having the largest. So clearly from this, if this is the base of cylinder, then clearly what I can say, height of the cylinder is equal to the side length and the diameter of cylinder. So diameter of the cylinder will be equal to the side length. From this r is equal to a by 2. So already edge length is given as 14. So height is 14 centimeters and this is 7 centimeters. Radius is 7 centimeters. Now what I need to find? So volume of cylinder. So volume of cylinder is given by pi r square h. Now since options does not contain pi, so we can write as 22 by 7 into radius square is 7 into 7 into height is 14. Now this 177 gets cancelled. So this is nothing but 22 7s are 154 into 14. Now clearly 4 4s are 16. So likewise also we can say the answer. So 2156. So if you multiply, what we are going to get? So 154 multiplied by 14. 4 4s are 16. 5 4s are 20 plus 1 21. So 4 1s are 4 plus 1 6. Next 1 4s are 4. 1 5s are 5. 1 1s are 1. So 6 5 11. So 2156. So likewise also we can say the answer by multiplying the units digit. So if you are having same repeated units digit, then you can go for direct multiplication. Next, total surface area of cube is 216 centimeter square. Then its volume is dash. So it is also 216 centimeter cube. right? So already we have discussed this in previous year questions. So what is the total surface area of cube? So 6 times of a square, so which is equal to 216 in 6 tables, so this goes 36 times. So from this I can say a is equal to 6 centimeters. Now since he is asking you to find out the volume, so volume is equal to a cube. So a cube means 6 cube, so 6 cube is equal to 216 centimeter cube. So here the units are very important. Next, a shuttlecock is a combination of. So you have seen shuttlecock, right? So shuttlecocks look like this. So this particular bottom part is nothing but looking like a hemisphere, and this top part is like looking like a frustum of cone. So from this what we can say, hemisphere and frustum cone. Next, TSA of solid hemisphere whose radius is 7 centimeters is. So radius is given as 7 centimeters. Now I need to find out total surface area of hemisphere. So total surface area of hemisphere is 3 pi r square. Now writing down the values. So since options contains pi, so 3 pi into 7 square. Now 3 pi into 49. So 9 3s are 27. So 4 3s 12. 147 pi. So this particular answer is 147 pi. Right. Next, moving on to question number 20. If the radius of base of cylinder is doubled and the height remains unchanged, its curved surface area becomes. So first of all, write down curved surface area of cylinder. So curved surface area of cylinder is nothing but 2 pi RH. That means curved surface area is directly proportional to radius into height, right? So it depends on radius and height. So from this, so what I can say, CSA 2 by CSA 1 is equal to radius 2 into height 2 by radius 1 into height 1, right? Now from this CSA 2 by CSA 1, I can write it as, so what is radius 2? So radius 2 is nothing but double of the previous radius, right? So we can write as 2 times of r, and heights remains unchanged. So height is as it is by initially the radius I am going to consider it as r and initial height is h. Now from this r can be cancelled, h can be cancelled. So from this what I can say, CSA2 is equal to 2 times of CSA1. That means second curved surface area. So when you increase the radius of the cylinder, then curved surface area will become double, right? So likewise we can prove it. Next, the number of cubes of side 2 centimeters, so which can be cut from a cube of side 6 centimeters is. Now if you observe this carefully, so biggest cube we are going to cut into small cubes of 2 centimeters side. Okay, so from this what we can say is, so volume of biggest cube is equal to n times of volume of small cubes, right? So volume of big cube, so volume of big cube means 6 cube is equal to n into volume of small cube. So volume of small cube is 2 cube. Now this 6 cube I can write it as 2 cube into 3 cube is equal to n into 2 cube. Now on both sides I can cancel out 2 cube and 2 cube. So from this n is equal to 3 cube is 27. Hence I can cut the given cube into 27 parts with each side length 2 centimeters. Next, the volume and surface area of sphere are numerically equal. Then the volume of smallest cylinder in which the sphere is exactly kept. Now what he has given? Volume of sphere and surface area of sphere. That means 4/3 pi r cube is equal to 4 pi r square he has given. So based on this I can cancel out 4 pi, and this r cube r square it cancels r times. So based on this what I got, r by 3 is equal to 1. So using which I can say r is equal to 3. So the radius of the given sphere is 3 centimeters. Next, what is asking, then the volume of the smallest cylinder in which the sphere is exactly fit. Volume of smallest cylinder in which the sphere is exactly fit. So inside a cylinder, so we have kept a 3 centimeter radius So we have kept 3 centimeters radius sphere. Now this is 3 centimeters and the height is 6 centimeters. Now what is he asking? The volume of smallest cylinder. So volume of cylinder is given by pi r square h. Now substituting the values pi into what is the radius of this particular cylinder. So it is 3 square into what is the height of the cylinder. So height of the cylinder is nothing but diameter of this. So 3 square is 9, 9 6 is 54. Hence the answer is 54 pi centimeter cube. Hence the answer is 54 pi centimeter cube. Next, if the diameter of a sphere is d, then its volume is. So volume of sphere is given as 4/3 pi. So 4/3 pi r cube, right? So already we know diameter is equal to 2 times of radius. So from this radius I can write it as diameter by 2. Now here substituting in the place of radius diameter, so d by 2 whole cube. So this I can write it as, so 4 by 3 into pi into d cube by 8. In 4 table I can cancel it 2 times. Then what I am going to get, 1 by 6 into pi d cube. So 1 by 6 into pi d cube is my answer. Next, question number 24. If the ratio of radii of two spheres is 2:3, that means r1 by r2 is equal to 2:3. Then the ratio of their surface areas. So surface area 1 by surface area 2 is nothing but given by r1 by r2 whole square. If it is volume, then r1 by r2 whole cube. This can be written as 2 by 3 whole square, so which is nothing but 4 by 9. Hence the answer is 4:9. A cylinder, a cone and a hemisphere are of equal base and have same height. Then the ratio of their volumes he is asking, right? So cylinder, cone and hemisphere are of equal base and same height. That means all the radius are equal. So following the order. So what is cylinder volume? So volume of cylinder. So V suffix Cy is 2. So volume of cone is 2. Volume of hemisphere. So this can be written as pi r square h is to 1/3 pi r square h is to 2/3 pi r cube. Now in this pi I can cancel it out in each and everything. Now since radius and height are same, now clearly here if you observe, so this is cylinder, right? And this is cone, right? And this is hemisphere. So here hemisphere height is nothing but radius only, no? So from this clearly what I can say, height of cylinder is equal to r. So instead of h we can replace r in both the situations. So here also h is equal to r, here also h is equal to r. Now this is written as r cube is to r cube by 3 is to 2r cube by 3. Now in everything, so I can cancel out r cube. Now multiplying each and everything with the 3, then I am going to have 3 is to 1 is to 2. Hence the answer is 3 is to 1 is to 2. Next, if a cone is cut into two parts by a horizontal plane passing through the midpoints of the axis, then the ratio of the volume of the upper part and the cone is. So what he has given, so there is a cone, so through the midpoints, so if this particular part is cut, right? Now if you observe this carefully, if the radius of this particular cone is r and height of this particular thing is h, then the height of the small cone will be h by 2 and the radius will be r by 2. So by using midpoint theorem, so we can say this, if this is r, then this will be r by 2. So then this part will be r by 2 and this part will be h by 2. Now what is he asking? Then the ratio of the volumes. So V1 by V2 is equal to. So volume of cone is given by 1/3 pi r square h, no? So I can write as r1 square h1 by r2 square h2. Now substituting the values. So r1 square is r square So what is he asking? The ratio of the volumes of upper part first. So upper part means, so this small part, okay, its radius is nothing but r by 2 whole square into height of first part is nothing but h by 2 whole divided by radius of the whole cone. So radius of whole cone is r, which is nothing but r square into this height is h. Now simplifying this, what I am going to get? R square by 4 into h by 2 into, so these two things can be brought to the numerator as, so 1 by r square into 1 by h. Now this h gets cancelled, r square gets cancelled. Hence the answer will be 1 is to 8. Hence the answer is 1 is to 8. Right? Next, the height of the cylinder is doubled and the radius is tripled. So height is doubled and radius is tripled. Then its curved surface areas will become dash times. Now already we know CSA of cylinder is given by 2 pi RH. Right? Now CSA is based on radius and height. Now here the radius is, so height is doubled and radius is tripled. So I can write as 2 into, so CSA dash is equal to 2 pi into radius is a triple. That means this can be written as 3 times of r into height can be written as 2 times of h. Now based on this, so what I am going to get? So when I multiply, so 2 3s are 6, 6 2s are 12 into pi r h. So instead of writing like this, so if I write 2 pi into r into h, then what I am going to get? 3 2s are 6. So this 6 into 2 pi rh. So already 2 pi rh is nothing but CSA of original one. So I can write as 6 times of CSA. That means CSA dash is nothing but 6 times of CSA. Hence the answer will be 6. Right? Next, moving on to question number 28. The diameter of a sphere which can be inscribed inside a cube of edge x centimeters is. So it's asking you to find out the diameter. Now a cube is there, so whose edge length is x, right? So inside this cube I need to put a sphere. Then what is the diameter of the sphere? So diameter of the sphere is equal to the edge length, hence the answer will be x. So the diameter of the sphere will be equal to the edge length of the cube, hence the answer will be x. Next, ratio of volumes of cone, cylinder and hemisphere on the same base is and having equal radius. So already we have proved. So if it is cylinder is to cone is to hemisphere, then it is 3 is to 1 is to 2, right? Now what did he ask? Cone is to cylinder is to hemisphere. So cone is to cylinder is to hemisphere means, so cone is 1 is to cylinder is 3 is to hemisphere is 2. So 1 is to 3 is to 2 is the answer. Next, total surface area of hemisphere of a hemisphere of radius r is, total surface area of hemisphere is given by 3 times of pi r square. Right? Next, volume of frustum of cone. So volume of frustum of cone is given by, so 1/3 pi. So 1/3 pi into capital R square plus a small r square plus capital R into small r into h. So the only thing that changes is, so 1/3 pi r square h is nothing but the formula of volume of cone, right? So here the same way we can remember this. So 1/3 pi, instead of r we are going to have two types of radius. So those radius are nothing but given by capital R square plus a small r square plus a capital R into small r into h. Hence the answer is option A. Right, next moving on to question number 32. If the length of each diagonal of a cube is doubled, then its volume becomes dash times. So what is diagonal of cube? So diagonal of cube is nothing but given by cube root of a. Right, so diagonal is cube root of, sorry, so root 3 into a. So diagonal of cube is given by root 3 into a. So from this a is equal to d by root 3. Now what he has done, so diagonal is doubled. So if diagonal is double, what will be the side? So a is equal to 2d by root 3, right? So if diagonal is doubled, automatically side also will be doubled. So when side is doubled, then automatically, so volume is equal to a cube, so which is nothing but 2a whole cube, which can be written as 8 times of a cube. So clearly it becomes 8 times, right? Next, if a right angled triangle is revolved about its hypotenuse, then it will form, right? So this is my right angled triangle. So according to this hypotenuse, if you revolve this particular thing, then I am going to form a double cone. So I am going to form a double cone. So if you rotate with respect to any one of the legs, then I am going to form a cone, right? Next, a solid sphere of radius 10 centimeters is molded into 8 spherical solid balls of equal radius. Then the radius of each small spherical balls is. Now already he has given, so one big spherical ball is converted into 8 small spherical balls. Now from this what I can say, the volume of this particular one. So 4/3 pi capital R cube is equal to 8 times of 4/3 pi small r cube. So on both sides I can cancel 4/3 pi. Now writing down the values. So this can be written as 10 cube is equal to 8 into small r cube. I need to find it out. Now this 8 I can write it as 2 cube. So from this r cube is equal to 10 cube by 2 cube. Now from this r cube is equal to 10 cube, I can write as 2 cube into 5 cube divided by 2 cube. So 2 cube gets cancelled. So from this r is equal to 5 centimeters. Hence the radius of the small balls is 5 centimeters. Right. Next, in a hollow cuboid box of size 4 into 3 into 2, the number of solid iron spherical balls of radius 0.5 mm that can be packed is. Now, so whatever the volume of cuboidal box will be, so that will occupy n number of solid spherical balls. So from this what I can say, so volume of cuboid is equal to n into volume of sphere. Now from this, so 4 into 3 into 2 is equal to n into 4/3 into pi. So pi I can write it as 22 by 7 into r cube. So r cube means, so 1 by 2 whole cube. Right. Now from this n is equal to 4 into 3 into 2 into this 4 by 3 I can write as 3 by 4 into 22 by 7 can be written as 7 by 22 into, so this 1 by 2 whole cube can be written as 2 cube by 1, which is equal to, so on simplification, so 4 can be cancelled, right? Next, so any more cancellations that are possible, so in two tables, so this goes 11 times, right? So what I am going to get, so 3 3s are 9, so 9 7 63, so 63 into 8 by 11, so 63 into 8 by 11, so which is equal to, so 63 8s are, so 8 3 is 24, so 8 6 are 48, 50, so 504 divided by 11. So in 11 table, if I cancel it out, so 11 4s are 44, so then I am going to have 64, so 45 times, sorry 11 5s are 55, so this is nearly equal to 45, so it is nearly equal to 45, so there is no option 45 in this question, right? So the answer is 45, so nearly 45. Okay, So but there is no option that is given here, or otherwise. So what he has to mention, so if he gives the thickness of the particular box, then so there might be some answer, so that would come out. But here based on this particular question, so we are going to get only so 45. So is there any mistake that is done? So 4 into 3 into 2 is equal to n into 4 third pi r cube. So r is nothing but 0.5 meters, so 0.5 can be written as 1 by 2, so 1 by 2 whole cube. So this is nothing but written as n is equal to 4 into 3 into 2 into 3 by 4 into 7 by 22 into so 2 cube. So here since in the denominator we are having 11, so that is the problem what we have, right? Next, moving on to question number 36. If the external and internal radius of hollow hemispherical bowl are r and r, then its total surface area is given by, then its total surface area is given by. So total surface area of hemispherical bowl is given by, so here it is hollow hemispherical bowl. So hollow hemispherical bowl means, so you will have 2 pi r square outside, so which is nothing but given by 2 pi into capital R square plus 2 pi small r squared inside, plus so there will be a ring that is formed, so which is nothing but pi into capital R square minus small r square. Now on adding all this, 2 pi r square plus pi r square, so this is nothing but 3 into pi into capital R square, so 2 pi small r square minus pi r square, which is nothing but plus pi into small r square. If I take pi as common, so then I can write as 3 times of capital R square plus small r square. Hence the answer is pi into 3 capital R square plus small r square. Next, volume of cylinder is given by pi r square. So these are all the theoretical questions what do we have. So volume of cone is equal to 1/3 pi r square h. Next, volume of sphere is given by 4/3 pi r cube. Next, volume of hemisphere is given by 2/3 pi r cube. Right. Next, volume of cuboid. So already we know length into breadth into height. Next, total surface area of cone is. So total surface area of cone is nothing but area of the base plus area lateral surface area, pi r square plus pi r n, or pi r into r plus n. Right. Next, total surface area of cylinder is nothing but given by 2 pi r h plus 2 pi r square, or otherwise you can write as 2 pi r into r plus h. Right. Next, total surface area of hemisphere. Total surface area of hemisphere is nothing but 3 pi r square, so which is nothing but none is the option. Next, moving on to question number 45. Surface area of sphere is. So surface area of sphere or total surface area of sphere both are same, and it is given by 4 pi r square. Next, total surface area of cube. So total surface area of cube is 6 times of L square, where L is nothing but edge length. Next, volume of a cube is given by a cube cubic units. Next, curved surface area of hemisphere. So curved surface area of hemisphere is nothing but 2 pi r square. Next, curved surface area of cylinder is, so 2 pi rh. The volume of a cube is 216 centimeter cube. Then its edge length is. So already we know a cube is equal to 216. Then a is equal to cube root of 216. So which is equal to 6. Hence the answer is option D. Next, CSA of cone. So CSA of cone is nothing but pi r l, or this can also be written as pi r into root over h square plus r square. Right. So these are the questions so related to the chapter mensuration, and in the next video so we are going to discuss the remaining questions. Right. So thank you for watching the video and stay connected to the channel for further more videos.